the email. Since we have access to the telephone API, we can actually read it. I don't know why every application should be able to read the hardware number, but we can do it. And since we want to download an application, I thought, yeah, why do we need to implement like some HTTP stuff and to actually send out the email, because we need to, of course, get the email to either the Symbian client server or to our own malicious server, so they can do all the signing. So, okay, we can just start the web browser, give it an URL, put the pass the email as a parameter, and then the backend server signs this file and then just presents this for the user to download. So the web browser will, if it sees this file, it will just download and it will ask the user, hey, do you want to install this? So the original plan was like this. We have attack the device, extract the email, send it to the backend server. The backend server will send it to the online signing system. The signing system is protected by a very, very cheap captcha. You see here. Oh, okay. Did I show? No. Where is the cheap captcha? No, okay. So the online system is only protected by a very, very basic captcha, which is in hex only. So you can use like the cheap ass online captcha breaking service and just break the captcha, sign your backdoor, and just send it back. And the user just needs to install it. So yeah, I already told you about the unique ID. You can also just query it by pressing *#06# or look on behind your battery. So yeah, so reading the email is actually a little bit ugly, because you have this. It's also completely asynchronous. The thing what I did, I just went to some website. I didn't actually read the API documentation. I just tried some samples. The one sample that worked, I made it nice and small, compiled it, disassembled it, and used it. Works pretty nice. This will be online, hopefully also. Starting the web browser is very small in comparison. Just save your URL. Of course, you always include some part for the email, so you don't need to some string manipulation. You can just copy it to the memory location of your URL and just overwrite the appropriate characters, and then you have a very small piece of code that actually launches the web browser, leaks your email to the malicious backend, and grabs the malicious binary. So I will also skip that. Of course, you have to sleep again, doing calling asynchronous functions. If you test a lot, always make sure you have a SIM card in the phone, because the GSM stack will not be running if there's no SIM card in the phone. So we will always wonder why it didn't work, and it worked last time. Yeah, the shellcode actually got quite big, so that's why I started moving stuff to the heap. So just on the two phones, just my first test pages, I just exploited an application and read out the email and sent it to my server, which also shows the user agent strings, just to test that it works. And it works nicely on the devices I tested. Okay, there we have the online signing. So that's the normal screen you see if you want to sign an application. You just put in the email number, your email address, upload the binary, tell which capabilities you want, and then you have to fill out this nice captcha. Yeah, the captcha is in hex only. If you see what's written underneath, letters A to F and numbers 0 to 9. So yeah, that shouldn't be a problem to break this. Yeah, you can actually break it very easily by just using some online web service which has a nice Perl API or Python or whatever. So we don't even need to write that code. We just write our exploit, break the captcha. The funny thing is you always also need to click on a confirmation link after you uploaded something, and then you get another email with a download link. You can very easily abuse stuff like Mailinator, these nice spam trap emails, where you have everything accessible over a website. You can just tunnel everything through Tor or some other anonymizer to click on these links and download your stuff. So the signing takes about 50 to 120 seconds, but there's just some artificial delay which is implemented on the signing website. So of course you need to occupy the user with a nice looking web page until the malicious download is ready. So this is just output of the script. I don't know if my company will allow me to put that online, but yeah, it's very easily to build it yourself. Yeah. So yeah, 80 seconds. Hopefully you get a website that keeps the user that long before the screen pops up for the download. So of course, yeah, the captcha breaker is not too good. So yeah, you can just go and use multiple captcha breaking libraries or services, or just do multiple requests. Yeah, they have Symbian has some rate limiting, I think by IAP and email address, but that shouldn't be a problem, I guess. So, and then after the malware is signed, the web browser will just download the sys file, and after that will just prompt the user, do you want to install it? And if you ever have installed Symbian applications you are used to, like pressing 5 times OK, yes, I want to install it, and yes, it's unsigned. Do you want to put it on your flash card or on the internal memory? And now you will also get a small. This is for developers only, but I think users will happily just press yes, because they're just used. Okay, they need to install something. Just press 5 times yes, 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 and everything is okay. As far as I know, this has been working for all the MMS viruses for, I don't know, 5 years or something, where you just get an MMS and say with some application in it. And the users are just used to do this stuff all the time, so I don't think it will really help. Of course, if you have a more security-aware user, then you don't have some of these problems at all. So what you could do, just make some website which says, oh, Symbian OS update, and the user will say, oh yeah, super update, or some game or whatever application, because the actual trick will be, since you exploit something that's maybe running in the background, the browser will just suddenly open and tell you, hey, download this exploit. Yeah, just download this exploit, and yeah. So of course you could just do some game side or something, but you could trick the user into believing that it's something good because it just came from nowhere, and that could only be the OS, of course. So I actually wrote a very small piece of malware. It actually didn't do anything. It's just something here, so I can sign it and play with this. It just listens on a TCP port, and I can telnet into it and give him some commands. Yeah, it is always started at boot time, which is very easy in Symbian OS, and yeah, it's has a cheap stealth mod. It just doesn't appear in the application list, but of course you could easily find it. It's not something fancy, but it's a very good demo. You could could just add like a very simple functions like call this phone number or reboot the device or send SMS or whatever. Of course I did not do anything. Yeah, so actually the whole exploit to read the email, start the web browser. You need to load 3 additional libraries called 10-6 calls. The final shellcode was about 1.3K. Yeah, more or less 2 weeks to get it running completely. The scripting was more or less trivial. Just some numbers on the complexity. So what could you do if you abuse the online signing system? So of course auto start. Of course self update is always nice, or installation of other utilities using stuff like silent install, which is just another add-on library which you could of course easily embed into your malware. Of course, access to the phone network, access to the address book calendar, and possible location tracking and stuff like that. Unfortunately, the really cool capabilities are not available, but this is a good enough list, I guess, to cause some trouble. Defense of really cheap list. Of course, don't install vulnerable applications. Something new. I think the capability system could need a small fix, where you separate the network capability, the network services capability into 2, so one for socket stuff and one for the GSM stuff. Probably this is kind of hard and will break everything else that already relies on that. Symbian should monitor their online signing stuff. I guess they do it. And last but not least, if you have a ARM version device that is based on the ARM version 6 CPU, then you probably have, or hopefully have, non-executable memory and secure against these basic attacks. Symbian OS can be really exploited like other OSs with simple buffer overflow, code injection techniques. The development, even the application development, I would say it's harder than other applications, but the shellcode stuff is not really that much harder. If you just use the appropriate tools, it's no big thing. So the Symbian sign system, which is always was said, the platform is really very secure because you don't have a chance to actually install signed malware, or malware cannot get signed, but you can even circumvent the signing stuff. Takes a lot of work, but it can be done. Another nice thing is that the return address stuff and the stack stuff is really stable. So if you have a binary and have it on different devices, all the addresses are more or less stable. Future work, I already talked about it. Do some return to libc or others techniques from other platforms to get around non-executable memory. Maybe break the capability system a little bit more, and of course find some O-days so you can actually use all the knowledge I just presented. I would like to thank some people. First Judith for sharing her Symbian OS knowledge with me. For also Ollie shared his deep knowledge of Symbian OS security, and Simon, Eric, Manuel, Julian for giving their devices to me and